In this lecture, we are going to discuss various methods for the generation of single sideband suppressed carrier. We have already discussed the methods for the double sideband, the suppressed carrier, double sideband, full carrier in our previous lectures. So this method is the single sideband suppressed carrier generation. So there are three main methods. The first method is called filter method because we will use a specific upper filter, and the second method is phase shift method, and the third method is waiver methods or third method. It is also known as a third method only because it is a third generation, so you can also say it a third method. So let's discuss first method. So first method is known as a filter method. As the name suggests, filter method, so it means that we have to design a appropriate band pass filter which can only pass a single sideband from the generated double sideband suppressed carrier signal. So that is the block diagram of the filter method. So the first one is the balance modulator. So where you have this is of course synchronous. So you have a carrier signal cos omega ct. You can write AC, no problem. So and the input is the MT, and then after that you are generating the double sideband suppressed carrier signal, and then you can pass that double sideband suppressed carrier through a particular or proper band pass filter, and then you will end up with the single sideband suppressed carrier. Either it can be upper sideband or either it can be low sideband depending on the design of the band pass filter. So if we write the spectrum of these signals, like the spectrum of the message signal, usually we use Fourier transform in order to see the spectrum of the signals. So the spectrum of the message signal, so capital M of F, because spectrum is represented in terms of frequency, so that is F. So 0 and plus FM and minus FM. So the spectrum of the double sideband, the spectrum of the double sideband suppressed carrier. So this one is minus FC. So this one is the low sideband, and this one is the upper sideband. Similarly here, FC minus FM. So this is the low sideband and this is the upper sideband. And the amplitude of that signal is half of amplitude. So we use appropriate band pass filter. We can pass only a one sideband and block the other sideband, either lower sideband or the upper sideband. Like the upper sideband of this and upper sideband of that one, or the lower sideband of this and the lower sideband of that one, depend on the designing of the appropriate band pass filter. So the band pass filter is something like that. If you wanna design, if you wanna pass the upper sideband, so that is the band pass filter whose frequency is centered at FC, and the upper sideband is FC plus minus FM. So and the spectrum of the suppressed carrier will be equals to minus FC and then plus FC. So minus FC minus FM and then plus FC plus FM. So this method has some disadvantage as well, like you have to generate ideal filter. Why? Because there is abrupt change from 0 to 1, because so you see, so this is the sharp cutoff between the upper sideband. There is no separation and sharp cutoff between the upper sideband and lower sideband. So that is why it is very difficult to generate such a filter practically. So there will always be some portion available from the other sideband to the other sideband, so to the generator. So suppose here if you have generated upper sideband, so there will be some portion from the lower sideband. So lower sideband and upper sideband, so there is a very narrow separation. So that is why you have to design a very sharp filter, so which is not that easy to design such a filter. But occasionally, or you can say fortunately, so it is good fortune that you can use this method for the speech signal. And the spectrum of speech signal is something like that one, that because the range of speech signal is 300 to 3400. So that is the higher side, and this one is the lower side. So if you write this in terms of the used upper sideband and the lower sideband, so you can see this is the FC. So this is the lower side and that is the higher side, and you can see there is a big separation between these two bands, like 600 Hertz separation. and the response of the band pass filter is something like that one. So it means that you can easily select one sideband, either upper or a low sideband from the speech signal, because there is a large separation between these two bands. So that is the fortunate for the speech signal, but so that is why the filter method is usually preferred only for the speech signal. So it is not used for other signal. So the second method is the phase shift method. So for the phase shift method, we have to use two balanced modulator and two Hilbert transform. We have already discussed what is the Hilbert transform in our previous lectures. So I hope you have understand that. So the input of that balanced modulator is the message signal and the carrier signal. And then taking the Hilbert transform of that carrier signal, you will end up with the AC sin omega CT that is given to the balanced modulator. And similarly, message signal is given to the Hilbert transform and then this balanced modulator. The output of that balanced modulator is x1t and the output of this balanced modulator is x2t. Then after that you are going to sum them up or taking the difference, and then you will end up with a single sideband suppressed carrier, that is yt. So what is x1t? So if you see from here, x1t is the product of the message signal and AC cos omega ct, mt multiplied by AC cos omega ct. So what is x2t? So x2t is the product of the Hilbert transform of the message signal and the Hilbert transform of the carrier. So that is m cap t and AC sin omega ct. So AC sin omega ct. And what is yt? So yt is x1 and then plus minus x2t. So like you can write yt is equals to m of t AC cos omega ct plus minus m cap of t AC sin omega ct. So this is the single sideband suppressed carrier. So if you want to prove it, so you can take an example of a single tone modulation of single tone message signal, so which has a one frequency. So mt can be equals to am cos omega mt, and the Hilbert transform of this one is am sin omega mt. So if you insert these values in this equation, so your yt is equals to am cos omega mt AC cos omega ct, and then plus and minus am sin omega mt and then AC sin omega ct. So am AC is common in both of them. So am AC and the remaining is cos omega c and then minus plus omega mt. So this is the single sideband suppressed carrier. So how we will get this signal? So you just use this trigonometric formula, which is cos A minus B. So this is A and this one is B. So this one is A and this one is B. So this one is A. So you can write this one is A and then this one is B. Like lower frequency is B and the higher frequency is A. So the formula of if it is sign is minus, then you can say cos A cos B plus sin A sin B. If the sign is plus, then cos A cos B minus sin A sin B. So similarly here, if it is plus and minus, then here it is a minus and then plus. So you can see this is either the upper sideband or the lower sideband. So this is known as a single sideband suppressed carrier. That is end for today lecture. I hope that you have understand these two methods for the generation of single sideband suppressed carrier. We will discuss the third method or the viewer method in our next video. I hope you understand this lecture, but if you still have any question, you can write your question in the comment box and we will try our best to answer the question. Thank you for watching the video.